Hello, good day and welcome to my channel. The question says solve the equations 4 log n in base 5 minus log m in base 5 is equal to 1 and 5 log n in base 5 plus 3 log m in base 5 is equal to 14. Now we're going to be applying the theory of logarithm in solving this problem. Now the first part here, if you look at this, you have you have 4 at the side here and you have n here. Now this number that is at the side multiplying the logarithm of this can be given to the value here as power. So that is one of the theory of logarithm, that when you have a number multiplying the logarithm of another number, then you simply take this number by the side here and it becomes the power of this number that you are looking for the log. So that means we can rewrite this now as log n raised to power 4 to the base 5. So that means this 4 becomes the power of n. Then minus log m to the base 5, and that will be equal to 1. Now this 1, which is a constant value, can be expressed in logarithm as well. What you do to express this as a logarithm value, you simply take the log of that base. Don't forget we are dealing with base 5 here. And then this same base 5, you write it and then you assign this value as its power. So it becomes 5 raised to power 1. So that is how to convert a constant number to a logarithm. So you take the log of the base that you are converting it to, and then that same base, and then you assign a power which is equal to the value here to that base. That is how to convert it. Now we can move on with the second one. We do the same thing to this second equation here. So I'm going to write it as log to the base 5 now. That is n raised to the power of 5. That is the 5 that is here becomes the power. And then plus log 5 to the base 5. And then m takes this power of 3. And that will be equal to, this number 14 can also be expressed in logarithm form. What we do there is to take the log of the base. The base is 5. And this same base, we write it down and we assign this 14 as its power. So it becomes 5 raised to the power of 14. So now that we have done that, we can apply another law or another theory of logarithm. Now, that theorem says that when you have subtraction of logarithm, it means you can divide the values of the numbers whose logs are taken. So you can simply take out log here. In doing that, you take out log to the base 5. Then we can open up bracket now. And then this value here, which is n, don't forget this is the question now. Our solution started from here. So this n raised to power 4, we are going to write it down. Then because of this subtraction sign, we are going to say divided by the value that we have here, m. And then that will be equal to log base 5 to 5. 5 raised to power 1 is the same thing as 5. So now similarly, we can simplify this other one too in the same way. But when we have addition, what we do is multiplication according to the theory of logarithm. So this becomes log in base 5. Then I open brackets. I'm going to say this n raised to power 5. N raised to power 5. Then multiply because there's addition here. Multiply by m raised to power 3. M raised to power 3, all close brackets, and that will be equal to log 5 raised to power 14, 5 raised to power 14, all in base 5. So now that we have log 5 here and we also have log 5 here, it means that what we are taking their log should be the same. So this n raised power 4 over m should be equal to 5. So that is what we are going to do next. So that n raised power 4 all divided by m is equal to 5. And then I can take this as my equation 1. Then similarly here, this log part, the base part can go, and then we say this is equal to 5 raised power 14. So n raised power 4 multiplied by m raised power 3. We can decide to write the m raised power 3 first since it has a smaller power. So I'm going to write m raised power 3 all multiplied by n raised to power 5, and that is equal to 5 raised to power 14. 5 raised to power 14. And then I call that equation 2. So that becomes equation 2. Now, the next thing for me to do is to look at equation 1. From equation 1, I can make m the subject of the formula. So when I cross multiply from equation 1, if I cross multiply there, let me write it down. If I write n raised power 4, n raised power 4 is equal to 5m when I cross multiply in this equation 1. From there, if I make m the subject of the formula, I divide both sides by 5. I divide both sides by 5. So from there, I now have 5 will cancel 5. I can write the m first. I now have m is equal to n raised power 4 all over 5. So now I have m as n raised power 4 over 5. Then the next thing, let me call this equation 3. Let me call this word, since we already have equation 1 and 2, let me label this equation 3. Now I can go back to equation 2. You can see equation 2 here. Anywhere I see m, I'm going to substitute it with n raised power 4 all over 5. So my m there, which is m raised power 3, I'm going to write n raised power 4 all over 5. That is the value for m now. That is the value of m. Then all raised to power 3. All raised to power 3. Don't forget, this is m raised power 3. And the value of m is already n raised power 4 over 5. Then all raised to the power here 3. That is what I've written down here. And then multiply by n raised to power 5. And that will be equal to 5 raised to power 14. 5 raised to power 14. Then now, simplifying this further, these powers will multiply each other, and this power will also affect the 5 that we have here. So this becomes n raised to power 4 multiplied by 3 is 12. N raised to power 12 all divided by this 3 will also affect 5. So it becomes 5 raised to power 3. And then all multiplied by n raised to power 5 is equal to 5 raised to the power of 14. So the next thing that I'll be doing here is to cross multiply. N raised power 12 multiplied by n raised power 5. According to the law of indices, when you have multiplication of terms in the same base like this, you add their powers. So these two are multiplying each other, so you simply add their powers. So 12 plus 5 is 17. So that will give me n raised power 17 is equal to, don't forget I'm cross multiplying. So this is multiplying 1 under here. It gives me n raised power 17. And then 5 raised power 3 multiplied by 5 raised power 14. So since they're also multiplying, I'm going to add their powers. Don't forget their bases are the same, 5 and 5. So you add their powers according to the laws of indices. So 3 added to 14 will give me 17. So I have 5 raised to power of 17. Then now, since their powers are the same, it also means that their bases will be the same. So I can conclude by saying that n is equal to 5. Because their powers are the same, it also means that their bases are the same. So n is equal to 5. So this is the value for n. Now let me go to equation 3. Hope you can see equation 3 from there. From equation 3, m is equal to n raised to power 4 divided by 5. So let me write it as equation 3. M is equal to n raised to power 4 all divided by 5 from equation 3. Now, don't forget that our n is already 5. So I'm going to say is equal to, that is m is equal to n raised to power 4. Okay, sorry, n is 5. That is 5 raised to power 4 all divided by 5. All divided by 5. So I can now say that m, don't forget we're looking for m, is equal to 5 raised to power 4 divided by 5. What you just need to do is to subtract the power. This is like 5 raised to power 1. So in indices, when you have the same basis like this, dividing each other, you subtract their powers. So it's going to be 5 raised to the power of 4 minus 1 is 3. So 4 minus 1, subtracting your powers, 4 minus 1 is 3. So that means m is equal to m raised to power 3. That is 5 times 5 times 5, 3 times, will give us 125. 5 times 5 is 25. 25 times 5 is 125. So finally, we can conclude now by saying that m is equal to 125. And then n, as we have obtained before, n is equal to 5. So these are the two final answers. Hope you enjoyed this video. Please don't forget to subscribe to this channel if you have not done so already. And please like and share this video for others to learn from it. And I'll see you in my next video. Thank you for watching.